Hi. Um, so thank you for being here, first of all. Every time I stand up in front of a large group of people, it is nerve-wracking, but after it's over, I enjoyed it, and I feel like it usually goes pretty well, so I'm hoping that we can all have a little bit of fun while I'm up here. So today, I'm going to be talking about auto-generating APIs from an existing Postgres database using tools like Django REST Framework and Django Filters. So in this talk, I want to try to dive into some of the specifics of how we go about doing this, talk about some of the situations in which it makes sense, and some situations in which it doesn't make sense, and try to give my sense of whether or not this is something that I recommend for other people to do. Spoiler, it is often not a thing that I would recommend for other people to do, but it's still a really cool, a really neat idea, and something that I would recommend people try, even if it's not something that you would need for your production application. So I realized earlier today that I didn't actually talk about what I mean by generating an API. And so I added these slides a little earlier this afternoon. And so at a high level, what I mean by auto-generating an API, you can think of an API as consisting of very high level 3 components. You have your database, your data store, wherever the stuff that you are serving out is stored, or the stuff that you are taking in gets stored. You have your views, or your external interface to your API. So in Django, this is views. And then you have your models, which serve as your interface, your internal interface between your external interface and your data. So there are a few ways that people generally go about constructing applications in general, and specifically APIs. A very Django way of doing things is to write your models and your views explicitly. So actually code up a models.py file, code up a views.py file, or whatever you want to call these things, and then use the rules that are built into Django to inspect the structure of your models.py file to generate a structure for your database. That's one way of going about things. Another way that some people go about things for APIs is they already have a database full of a bunch of data, and then they build models.py files to act as the interface on top of that data between the database and their views. What I'm talking about when I say auto-generating an API is more something like this, where you start with a database full of data, you use a set of rules to inspect that database and build models, which you then use to build views, build an external interface for your API. So you don't explicitly code your models, you don't explicitly code your views, you just build rules to take the data in your database and construct models and views on top of that data. Very high level. All right. So that's the what about this endeavor. So now I just want to talk a little bit about why we decided to build an API. And actually, let me back up and tell you a little bit about who we is and who I am, for that matter. So I'm the CTO of a company called Stepwise Analytics. We build tools for helping people to make smarter and more impactful real estate investment decisions. So a lot of the data that we use for these tools comes from open data sources, data that's published by governments from city level up to the federal level. So we work with a lot of open data. And when I say a lot of data, I'm not like talking about, for example, we're not working with human genome level big data kind of data, but we are working with data on the level of, for each of the cities that we support, a few dozen gigabytes of data for each of those cities. So it's a significant amount of data, and it's split up into a significant amount of data sources. A little bit about my background with these kinds of data sources. So before I was at Stepwise, I used to work with the City of Philadelphia in the Open Data and Digital Transformation Office, the Office of Open Data and Digital Transformation. Before that, I was at Open Plans, a company up in New York where we made tools for helping citizens to get involved in the urban planning process. And before that, I was a Code for America fellow. So I've been working around government open data sources and in the space of government open data for several years. And in that time, I've learned a few things about these kinds of data sources. So in my experience, government data sources can be scattered. So there are a number of different places that you might look and find data sources that are related but not directly connected to each other. They require a lot of cross-referencing and cleaning up in order to do that cross-referencing. There are a number of them across different departments. So the government of a city as a whole is generally not the one that's producing data sets for that city. It's usually licenses and inspection in the city and the Department of Records and all of these other independent entities that don't necessarily communicate about what the single format around that data, single schema around different things that should be included and so on. So these data sets can be scattered. Moreover, oftentimes you'll find that data sets pop up and disappear without warning. And more often, within any particular data set, you'll find that new fields appear or disappear without warning. And these are all things that we just have to deal with in dealing with open data. We, Stepwise, we had to come up with some place to ensure that the data that we were using and serving up to our application through our API met certain expectations. And so we built an entire data pipeline around ingesting all of these different data sources and built in certain expectations to that data pipeline. And what we initially did was, in addition to building in expectations in the pipeline, we also created models by hand for each one of these data sources that we were pulling in from all these different cities. What we found is that because we were repeating ourselves, we were building in expectations about what the data was going to be structured like at the data pipeline level, and we were building in expectations about what the data was going to be structured like at the application level. Those things often got out of sync. And so, in order to stop repeating ourselves, we said, well, why don't we try instead auto-generating our API based on the data that we're getting in? Since we're already checking that the structure of this data meets certain expectations, though we wanted to be flexible enough around where it didn't need to meet hard expectations. But as long as it met certain expectations, we wanted our API to run with it. So we decided to start auto-generating our API. So this is all of those reasons that I just laid out. So there can be a lot of different tables coming from a number of different sources. The schema of those tables may change on a regular basis. And our table structure was already defined elsewhere, specifically in our data pipeline. So we didn't want to repeat ourselves by defining it as well in the application layer. So that's the what and the why around our approach to generating an API. Now we're going to talk about the how. So at a very high level, these are the steps that we take. So first, we inspect the database. Based on that structure, we create models. Based on those models, we create serializers and filter sets. Serializers are a Django REST framework construct, and filter sets are in Django Filters, which works with Django REST framework. And then based on those, or using those as well as a few other things, we create and expose views. So this seems pretty simple, and like all things simple, it's actually not. But at a high-level view, this is the general process. And I'm going to dive into each one of these points on their own. So we start with inspecting the database. And this is really just figuring out what is in your database. And so the way that we do this is with something called introspection. Introspection is actually a term that comes from psychology, I believe, and it's the process of asking oneself about oneself. How am I feeling? What am I thinking? So much like introspection in psychology is asking oneself about oneself, introspection in databases or in programming languages is about asking that database about itself. And so there's a tool that we use to do this that's called the information schema. So the information schema is an ANSI standard, and as such, it's supported among most of the major relational database management systems. And there are slight differences between what's available in each one of these relational databases. But by and large, the information schema is a thing that you can use to ask the database about itself. So it gives information on columns, tables, views, and procedures, as well as a number of other objects that exist in the database, indexes, and so on. And there are some difficulties that you may run into when working with the information schema. For example, since we deal in real estate data, one of the things that we have to use a lot of is geographic data. And so we use an extension on top of Postgres called PostGIS, where the GIS is GIS. It stands for Geographic Information Systems. And that is a Postgres-specific it builds a set of specific objects within the database that you can use for managing geographic information systems. Now, PostGIS object types don't always fit very well into the information schema. And so that's just one example of where a database-specific feature doesn't always make its way into the information schema in a clean and clear way. But for the most part, you can query just about anything about all the objects in the database that you want, again, with some caveats, but just about anything you want through the information schema. And you query it just like you use normal SQL to query the information schema. It looks something like this. So this is an example that's similar to some of the code that we use in our code base to query the information schema. In fact, I will show you what this actually looks like. And can people read that text in the back? Yeah, all right. So this is actually what it looks like when we query the information schema. So, instead of just asking for table name, column, data type, and whether it's nullable or not, we're actually asking for all of these different fields, because all of these different fields may come into play when we're determining what type of thing we're pulling out of the database. But this is essentially asking for all of the different columns that exist in the schema that we are concerned about within our database. There are some things here that are ill-advised in database programming. I was talking with Tim a moment ago. It turns out that both us at Stepwise and them at Wharton are doing these kind of auto-generating of APIs. And one thing that we were talking about was that there are, in both of our code bases, a lot of things that you might kind of scratch your chin at and say, really, do you want to do it that way? But it works, and it's still kind of neat. So this is again just pulling out all of the columns in our schema, ordering them by table so that we can start to get a sense of what models are in our database. So with that tool, with the information schema, we're able to know what's in the database, but we still need to tell Django what's in there. And also, if we want to use all the awesome tools with Django or that come with different Django packages like Django REST Framework and Django Filters, then we need to create some models. So Django loves models, and when I say Django loves models, I don't just mean like the core of the application platform that we all know and love, but I mean the community Django and the ecosystem of tools and add-ons that is Django loves models because they are this consistent extendable interface on top of so many types of different data systems. So there's good reason for Django to love models, but one of the implications is that it becomes very difficult to do anything with all of those different add-ons in Django without having models. So we have to create some models. The way that we create models, we at Stepwise, because it turns out there's 1,000 different ways to do anything. And again, in my conversation a moment ago with the folks, or with Tim from Wharton, we're doing this in slightly different ways. But the way that we're doing it at Stepwise is with metaprogramming. So what we're doing is we're building up. So for those that aren't familiar with metaprogramming, the idea behind it is that you're building up programming components using other programming components. So in this case, what we're doing is we're creating classes using functions as opposed to explicitly writing out classes. So this is kind of an important concept in the way that we're auto-generating this API. So I want to make sure that it's clear to everybody what it means. So quick introduction to metaprogramming. Let's say you have the following. Now, most people in the room will understand what this means. This is creating a model called myModel. That's the name of that class. It is extending the class models.model. That's the set of bases. It's a set of one base class. And it is adding an attribute to that model called myField. So fairly simple model here. But let's say you needed another one that looked similar but had a few differences. So maybe you copy and paste this one and create a model1 class that also has a myField. Maybe it has myField1 or it has some slightly differently named attribute. Now let's say you need another one. So you could copy and paste in your models.py file again. All right, so now you have 3 model classes that all look about the same but are slightly different. Let's say I don't need 50 of these. Then after a while, you start adding and adding to your models.py file, and this is a bit hyperbolic and is very much a toy example because there's not much utility to 22 models that all have a single field called myField. But at the same time, I have found myself in a situation where I have a models.py file that's several thousand lines long. And it could be split out into multiple models.py files or multiple into a package that has multiple modules within it. But there would still be thousands of lines of code to maintain in there. And instead of doing that, one thing that you could do is a little bit of metaprogramming. So for example, this code here will create 50 different models. This code here will create 50 different models named myModel0 to myModel49. It will give it a set of base classes, a set of one base class called models.model, and it will add some attributes to that model, a set of one attribute called myField, and then it will create a class from that name, set of bases, and set of attributes. That last line, set attr on this module, name model class, is because of the way that we are getting Django to recognize our models. They have to be registered within the models.py module at load time. So we have to actually bolt them onto the models.py module. So it's a little bit of a hack, but it works. Now the astute among you may say, well, do you really need some metaprogramming to do this? No, you might be able to just do this, right? You might be able to say, okay, well, I have a for loop, and there is a typo in this code. But I have a for loop, and I'll just put a normal class declaration inside of that for loop and add each one of those classes to my module. However, the challenge starts when you need more than a single attribute called myField on each one of those classes. If you don't know all of the different attributes that you need to put onto those classes beforehand, then you're back to needing some more powerful solution. And the beauty about metaprogramming is that you can treat the attributes on a class just like data. You can create a dictionary of attributes for the class that you're creating. So let me show you what this looks like in practice as well. It's a little bit less clean than that simple for loop that I showed before. But this is essentially, let's see, make API models. Yeah, this is essentially the function that we use to create the models in our API. So it goes through, it creates attributes, creates base classes, a set of one base class, and creates a name for each one of the models. And then it actually uses what's called a count caching geometry aggregating query set as the manager on those models. And I'm not going to go into the geometry aggregating piece, but it's a really long name, and that's OK because I only use it once. But I will go into the count caching part of that later, not the geometry aggregating part, though. That's going to be out of the scope. And I have plenty of opinions on integrating geometries into all of this thing. But I'm not going to talk about all of those opinions because I don't have quite enough time. So if you want to know more about integrating geometries and GIS type stuff into this kind of thing, talk to me. All right. So let's move on, though. A note about primary keys, right. OK, so the Django ORM requires a single primary key field on every model. Now, because we don't control entirely the data that we're ingesting from all these city sources, I also learned a neat trick when I was talking to Tim about this. But because we don't control all of the data that comes in from all these sources, what we do is we actually add a throwaway field to each and every table when we create that table in our data store. And we use a tool, an awesome tool. This is an awesome tool, by the way. It's called dbt I think it stands for database tool, honestly. But it is really good. It's from, shout out to Fishtown Analytics. There's some folks out of Philadelphia. And it allows you to manipulate your database with SQL queries, but templated SQL queries. It actually uses Jinja templates so that you can do things like, instead of creating gnarly, huge SQL queries with all sorts of nested SQL queries inside of them and so on, which is sometimes necessary, you can include SQL queries from other SQL templates. So it's actually, that's one of the things that it does, but it's an awesome tool. You should check it out. All right, so after this, we have our models. So the next thing that we have to do is create the serializers. And this is actually a lot simpler than creating the model, so it should be quicker. Well, let's see. Yeah, it involves less metaprogramming, not none, but less. It subclasses the model serializer class, and we exclude the primary key that we added because Django needed us to. So this is what our serializer creation function looks like. So here is where we're actually getting rid of that primary key, because it is useless for us to expose that Django ID. It doesn't mean anything. It's just an auto-incrementing number that we add onto each table because we had to. So we get rid of it when we serialize the data for rendering through the API, and then we create a model serializer class that points to each model, and yeah, that's that one. So serializers, again, are relatively simple, and the filter sets are slightly less simple, but still not too bad. So the way that the filter set generation works, oh, by the way, so for those of you who don't know, have never been exposed to Django Filters, Django Filters, the package, not just filters in Django's, for example, on query sets. But Django Filters is a package that allows us to make queries in our API that are Django-like. For example, this one here, this is a sample query string where we're saying, okay, well, give me everything where the region is in a single region. It could just be region equals PHL, and improved area is less than or equal to 3,000 feet, and vacant is true. So it allows us to construct query strings like that will just pass that information. It will actually validate that information and then pass it along to our query sets. So we determine what filters are available based on the type of each field, and then we also add in our own custom filters to Django filter sets. So that code is also not particularly interesting. It simply loops over each one of the tables in the database, gets the model class for that table, generates the names for each one of the fields. It comes up here and says, all right, if it's a character field, then you can do these things with it. If it's a integer field, you can also do these things with it. All fields, you can do these things with. And it just creates those sets of those filter sets for each one of your models, so that you can do things like query from your API. So the last thing that we need to do is create and expose the views, or or rather the view sets. So Django REST Framework has a concept of view sets, which are essentially collections of views that are bottled up into, well, they're essentially class-based views. They're very similar to class-based views in Django. But they're based around each one of your resources. So you can say, okay, for this resource, I want to have a list, a detail, a create, and an update function. And all of those are exposed at different endpoints or with different HTTP methods. So the view set creation code for us is mostly straightforward. It does require some more meta programming, and it does. And one of the things that we do is start to auto-generate some of the documentation. I don't know how many people in here have ever seen Django REST Framework auto-generated documentation? How many people have used Django REST Framework? Let me ask that. And how many people have used the Browsable API feature on Django REST Framework? Okay, so that documentation feature that comes with the Browsable API, where you can set the essentially, for each one of our endpoints, we build up a set of documentation that if you go to that endpoint, you can see the documentation for using that endpoint directly on it. There are also fancier ways to do this. Again, I have to keep referring to the work that they've done over at Wharton because I got a tour of it from Tim, and I'm just like, oh my God, this is great. But we have been trying to solve some of the same problems independently within the same city somehow. So, as I said, generating these view sets requires a little bit more meta programming where we are grabbing the table name, generating the name of the view set, using a whole bunch of base classes that do things that are somewhat outside of the scope of this talk. Some of them are. And then creating the actual view set using the type meta class. And one of the things that I didn't talk about in meta programming is meta classes. And a meta class is essentially, for this purpose, it is a thing, it's a function that will return a class object. Not an instance of a class object, but a class itself. So this, when we're calling type here, we're using type as a kind of meta class. Type is the meta class of most classes by default. But we're using type as a meta class, as a function, to create a class object. Just like we did with model base, which is actually the meta class for models.model in Django that it uses. So we use that model base class to create our model classes. But they're all just functions that create classes. So, additionally, with view sets, you'll also want to set up throttling, authentication, permissions, pagination, and any special renderers that you might want to use. Most of those, again, are out of scope for this talk, but there are two things that I want to talk about, which are the permissions and the pagination. So as far as permissions go, we wanted our API to be consumable by our clients, but not all of the endpoints. So the thing that we decided to do in our API was use Django REST Framework's permission framework. So first what we did was we created an access profile that is attached to each user and essentially tells which routes, which resources a particular user can access. We then use that auth profile or that access profile in a Django REST Framework permissions class that is derived from isAuthenticated, and essentially just checks whether the user is authenticated, and if they are, well, if they're not, then they can't access this resource. But if they are, then we've added a function to all of our views. This comes from one of those base classes on the view sets. So it adds a function to each of the views that allows us to get the endpoints that the user is requesting, and allows us to check whether the user has access to that endpoint. So the other thing that I wanted to talk about was pagination. Not specifically pagination, but really just counting in the API. So by default, Django REST Framework pagination classes include the total count of records that match any particular filter that you throw at them in the response. Now, initially, I didn't think this was going to be a problem. I thought databases were pretty fast at counting how many things match your query. And it turns out they are. When I say, fast, I mean like milliseconds, not seconds. It turns out it's closer to seconds when you get up to millions of rows of data. So that is too slow when you're talking about an API that an application is being built on top of. So in order to get around this, what we had to do was implement our own pagination class. And by the way, it is awesome that Django REST Framework even allows you to do this. That it had that Tom Christie and everybody who works on Django REST Framework, all of those awesome people, had the foresight to say, maybe people are going to want to customize the way that they paginate their data in the API. So specifically, we use something called a conditional count pagination class, which subclasses limit offset pagination. And if the user includes a certain query parameter in their query, then we give them the count of the objects along with the results of their query. If they don't, then we don't count the objects. All we do is we give them the response. This speeds things up dramatically. If you've never experienced this, I kid you not, you would be surprised how long it takes the database just to count the things that it is able to return to you. But otherwise, Postgres is wonderful. It just takes a long time to count. So we have this custom paginator, and we override a few of the limit offset pagination functions, specifically paginate query set, where we only include the count if we are asked to. Otherwise, we just skip it. Get next link, because in Django REST Framework, you have a link to the next page of results. And the way that Django REST Framework works is if you don't have any more results on the next page, then it won't give you a next link. It'll just say no. If you have not asked with our paginator, if you have not asked for the count, then we always give you a next link. And you just have to check it and see if there are any results there. But it turns out that this, for our use case, is faster than including the count with every page of results. So at this point, we have an auto-generated API. We've created our models. We've created serializers and filter sets and views as well. And now people can access data all the way from the database out to their browser. So, in conclusion, should you auto-generate an API? So my recommendation would be, if you just have a few tables, no. Just create models for all of those tables. And what's a few? It's really up to you. It depends on how many fields are in those tables and how complicated your logic gets when dealing with each one of those tables, and how customized your logic is in dealing with each one of those tables. For us, the number of tables that are generally served by our API is somewhere on the order of several hundred. For some folks, it's several thousand. But if you have fewer than like 40 or so tables, no, don't do it. Just maintain your models.py file. If the majority of your data is user-generated, I wouldn't recommend you do this either, because you're not starting from an existing data source. Your data is coming from your users. And so there's really no need for you to go through the extra headache of spinning up a database to do a bunch of extra logic on. You should just let Django handle your migrations and manage your database if most of your data is generated by your users. If you can trust your schema to be predictable, and this one's a little I'm not sure. Because if you can trust your schema to be predictable, but it's still thousands of tables, thousands of predictable tables, then maybe you should auto-generate your API. But you could go either way. You could just generate your models.py files. There are tools to do this. You could use InspectDB, but that has some drawbacks. The folks at Wharton are using, I know I'm just fanboying on Wharton at this point, but the folks at Wharton have developed more sophisticated methods of generating models.py files, and we should totally all open source this stuff, but it takes some time. But yeah, if your schema is predictable, a better choice might just be to generate models.py and leave it at that. So would I do this again if I had the chance to go back in time? I don't know. It's still kind of neat. And for that matter, we've been running on this for upwards of 2 years at this point, which is a pretty good time for any particular system. I mean, it's still going. Sometimes it's a little bit of a headache to maintain and to have to go in and fix something for a particular endpoint and not have it break all the others. But I don't know. It's all trade-offs. So if you're creating a data warehouse and none of those points above apply, then maybe you should use this method. Otherwise, I'm not really sure. But it's still neat, and I would recommend it just for your own edification. That's it.
Thank you. I was just curious, do you have a lot of relationships you have to work with? In my job, we've got a lot of relationships, and that didn't seem mentioned. Right.
No. And that is useful. It is useful to not have a lot of relationships to work with in this case. I have thought about that a lot because there are a lot of relationships that we could build into the database. It just happened to be that we weren't when we put this together. Mm-hmm. And if we did, it would require rethinking the way that we do a few things. Specifically, in reading in introspecting the database, right now we're not picking out any kind of foreign key relationships, any kind of any of that stuff. So we may move in that direction in the future. I don't know whether we will use this exact same method if we do.
Custom paginators are going to be a solution to a problem we're facing in production right now. Thank you for that tip. Have you given any investigation to using explain plans from the database to get the counts faster?
Yes.
Your thoughts?
Ultimately, it was a better use of my time to just do the custom paginator. So I spent a lot of time trying to explain what in the database was taking so long. And ultimately, I tried a number of things. One of them was just using an estimate of how many things were in the database or in a particular query as opposed to the exact number. But it turns out for a number of reasons, sometimes we need the exact number. And so for our use case, this was just the best solution. There are other approaches that people might be able to take in terms of estimating the number of results, but for our use case, this was the best solution. I guess, the best, I don't know. It was the solution that I came up with at the time.
Thank you, that was really great. I was wondering if you do any tricks or anything, or if it's fast enough, when you do application restarts, but maybe you only have one new data table, if you like cache them or anything, because you're pushing everything onto the stack on start.
I know. Right, so caching tables, or rather, caching the information about tables is something that we've considered. It just hasn't been something that we tackled yet. We're 4 people right now, and growing, by the way. But it just hasn't been something we tackled yet. So something I was thinking about is at the end of our data pipeline refresh, maybe we dump out a SQL representation of the schema, and then we can just read that in as opposed to going all the way to the database and running those queries because that does take, not an inordinate amount of time with hundreds of tables. It's maybe like 30 seconds or so, but yeah.
Hi, it looks like when you get a data set that's different from your previous data sets, that's going to change all the filters on your API. Mm-hmm. So the interface for clients is going to change. Have you done anything to control for that?
So there are things in our API that are okay to change. Some things are not, and those things we check for at the data pipeline level. For the things that are okay to change, right now we just let them change. And we do get notified when things do change, and so we are able to let clients know and so on, and we're able to respond to it internally, but there are just things that are okay to change. And for those things that are not okay to change, we respond to it earlier than at the application level by building those checks into the data pipeline.
Thank you again, Mjumbe. You ready for the next speaker? Okay.